All right, ladies and gentlemen, so in this next video, I'm going to review examples 4 through 7 from section 1.6. Now, remember, this is the last section for your test, so I'm actually going to start sharing my whiteboard in a minute and go over some of the examples. So if we go to your textbook and we look at example number 4, which, if I am not mistaken, is on page 43, I believe it is. All right, example number 4 says, solve an inequality with a variable on both sides. So we're going to solve an inequality with a variable on both sides. We're going to solve the inequality and we're going to graph it, okay? Solve an inequality with variables on both sides. So the inequality that we have is actually 5x plus 2, 5x, let's see if I can draw that better, 5x, there you go, well, it's better than it looked before, plus 2 is greater than 7x minus 4, is greater than 7x minus 4. 7x minus 4. So solving inequalities with variables on both sides is the same, or involves the same steps as solving equations with variables on both sides. So I can technically start with the 5x or the 7x, or I can start with the 4 or the the minus 4 or the positive 2. It doesn't really matter, because since they're linear inequalities, it's going to give me the same answer regardless. So I always like to keep my variables positive. So I'm actually going to start by subtracting 5x. So if I subtract 5x, this cancels out here. And I do the same thing on this side, 7x minus 5x. This is actually going to be, well, this cancels out, and that would be 2 is greater than, and 7 minus 5 is 2x, so that would leave me with 2x minus 4. Now, what I want to do now is get rid of the minus 4 so that everything stays positive. So obviously, I just add 4 on both sides. So I add 4 here. And that's just going to be 6. So 2 plus 4 is 6. Obviously, this side cancels out completely. And this would be 6 is greater than 2x. So I divide by 2. Now, when you're dealing with inequalities, especially when you're dividing them, you want to make sure that the number that has the variable is positive. Since I'm dividing everything by 2x, I have to make sure that this 2 is positive. Because if this 2 were negative, that would cause the inequality sign to flip over. But in this case, since 2 is positive, nothing really changes, and that turns around. And then 6 divided by 2 is 3. So that means that 3 is going to be greater than x. Or if we want to look at another side, that means that x is going to be any number smaller than 3. Remember what I explained in the previous class. If the inequality sign is facing the number, it usually goes to the left. So I'm going to change the color for a minute, because if this is confusing for you guys, you can always just do this. Right? X is less than 3. And if this helps you out, you can change it. I mean, if you understand that as long as the inequality sign faces the number, my arrow is going to go to the left, that's fine. But if it confuses you, you can always opt to do that. So if I'm going to graph this inequality, it says any number less, x is going to be any number less than x. Now it's not including 3 as part of my answer, so that means that the inequality, the point is an open point, and all I had to do is just draw the graph. And that would be the answer. 3 is less than x. Okay, and that's example number 4. Example number 5, ladies and gentlemen, is the same thing, but our equation varies ever so slightly because it's in a compound inequality. Okay, so I'm going to go ahead and clear this image. And now we're going to solve a compound inequality. Solve a compound inequality. This is example 5. And the inequality that we're going to work on is -4 is less than 6x Whoa, let me erase that. If I wanted to draw a teardrop, it would not come out as pretty as that one. 6x -4 is less than 6x minus 10 is actually going to be less than or equal to 14. Less than or equal to 14. So what this means, ladies and gentlemen, is that my inequality is not my answer when I graph it. It's not going to be an array like the previous example where x was less than 3. It's actually going to be a segment. So how would I go about working with this? The same way you would go about working any other equation. I want to isolate the 6x, so I have to get rid of the 10. So that means that in order for me to get rid of the 10, if it says minus 10, I have to add 10. But the difference is that I'm going to add 10 to every part of this inequality. So this is going to be 14 plus 10 on this side, and -4 plus 10 on this side. And what's going to happen now is that this is going to cancel out, obviously. The -10 and the -10 cancel out. And that leaves 6x. So I pass 6x over. And then I work with each side individually. And that means that -4 plus 10 is going to be positive 6. So obviously, this would now be 6. Not done with my equation yet, or my inequality yet, because I still have the 6x. And of course, 14 plus 10 is 24. So that would be, right, less than or equal to 24. And now, the next thing I'm going to do is divide by 6x. And again, I want to make sure that if I'm dividing by 6x, this 6 is positive. Because if this 6 were negative, that would cause the signs of the inequality to change. But since 6x is positive, no harm is done and everything remains the same. So we're going to divide each side by 6. And we divide this side by 6 here. And we divide this side also by 6. And this would, obviously, the middle part would cancel out, and I would finally have my x isolated, which is what I want. And 6 divided by 6 is 1, so I'd write here, I'm going to do it on this side, 1 is going to be less than x, because we already have our x isolated. And now we're going to divide this. So 24 divided by 6 is 4. So we say x is less than or equal to 4. And now I don't have an array like I did in my previous example. I have a segment. So that means that x is going to be any number greater than 1 but less than or equal to 4. So that means the possible numbers that would make this statement true are between 1 and 4. And if this confuses you, again, I said just think of a number and you want to see if this statement is true. Just think of a number that's greater than 1 but smaller than 4, and you would say, well, 3. Is 3 greater than 1? Yes. Or is 1 smaller than 3? Yes, it is. So this makes the statement true. 1 is smaller than 3. And is 3 less than or equal to 4? Yes, it is. So that statement just means that my x, the answer for x, is going to be between any number that is greater than 1 but smaller or less than 4. So how do I go about graphing it? Well, very simple. Remember, we have a compound inequality. So that means I'm going to start at positive 1. But since 1 is not included, that is an open point. So I leave it expressed like this. And it's going to end at 4 because it's between 1 and 4. And 4 is included in my answer. So it's going to be a segment between 1 and 4. And that would be the end of that exercise. That is example number 5. Now we're going to go at example number 6 real quick. Example number 6 says solve an or compound inequality. So we're going to have two inequalities that we're going to solve. So let me clear the drawings. And this is example number 6. So let me clear all this. Example number 6 says solve an or compound inequality. Solve an or compound inequality. Solve an or compound inequality. And that would be example number 6. And we're going to look at this. And the first problem that we have is 3x plus 5 is less than or equal to 11. 3x plus 5 is less than or equal to 11. And 5x minus 7 is greater than or equal to 23. And 5x minus 7 greater than or equal to 23. So what we're going to do is we're going to just solve each inequality individually, and we're going to have on the same number line two different possible solutions. So that's why it's called an or compound inequality. So the first thing I'm going to do is I'm going to subtract 5 on this side. We're working on this problem first. And 11 minus 5 is going to equal 6. So obviously this side cancels out. And I pass over my 3x to the final answer, or to the next part of the inequality. And I subtract 11 minus 5, which is 6, and less than or equal to. Now again, we want to make sure that we're going to divide by 3. We want to make sure that 3 is positive. I mean, if it were negative, it's not that it would make a difference. It's just that in that case, the inequality sign would have to change. But since the 3 is positive, I divide by 3. And I also divide by 3 on this side. And this cancels out. And 6 divided by 3 is 2. So it'll be x is greater than, or less than, excuse me, less than or equal to 2. So I did the first inequality, and I'm going to do the second one. So I have 5x minus 7 is greater than or equal to 23. So I add 7. That's the first thing I'm going to do to isolate the 5x. And 23 plus 7 is going to be 30. So I'm speaking faster than I'm writing. And it's because this is a very challenging thing to do. Anyway, so this side cancels out. and that is 5x is greater than or equal to 30. And you're going to divide by 5. Again, making sure that the 5 in this case, which is the coefficient that I'm dividing, is positive. And because it is, that means that my inequality sign does not change. So that would be 5. And 5 on this side. And this would cancel out. And 30 divided by 5 is 6. So in this case, x would be greater than or equal to 6. So you actually have, in this case, two possible solutions. One where x is going to be less than or equal to 2, and the other one where x is going to be greater than or equal to 6. Now, how do I graph that? Well, we have one number line, but we're going to have the rays moving in opposite direction. That's why it's called an and or compound, because it's probably going to move to one side and the other side at the same time. So the first part says x is less than or equal to 2. So if positive 2 is here, then, and it's less than or equal to, so that means that 2 is part of the answer. That means the arrow is going to move to the left here because it's less than or equal to. Again, another way, another hack, I don't know what you want to call it, of memorizing this is that if the inequality sign is facing the number, that usually means the graph is going to go to the left. And if the inequality sign is facing the variable, that means it's going to go to the right. So x is less than or equal to 2. It faces, the inequality sign is facing the 2, which means that the graph moves to the left. And if I look at the x is greater than or equal to 6, the inequality sign is facing the x, which means that the graph moves to the right. So that brings me to the next part of the graph that we're constructing. And it says x is greater than or equal to 6. So what that means is that in that case, x is going to be any number that's greater than or equal to 6. So to make this statement true, think of numbers that are greater than 6, 7, and so on and so forth. So this graph, this other graph, would actually be facing to the right. Okay, so that's example number 6. Now we're going to see example number 7, which is your favorite in mine, a story problem. I know a lot of people don't like story problems, but I think I have a little bit of a soft spot for them. So example number 7. Example number 7, I'm going to read the story problem to you, and then what I'm going to do is I'm going to map out the information that we have. Okay, it says biology. A monitor lizard has a temperature that ranges from 18 degrees Celsius to 34 degrees Celsius. Write the range of temperatures as a compound inequality. Then write an inequality giving the temperature range in degrees Fahrenheit. Okay, so we have a compound inequality. It means that it ranges from 18 to 34 degrees Celsius. 18, so the temperature of the lizard ranges from 18 to 34 degrees Celsius. So they want us to write a compound inequality. So that means that C is going to be greater than or equal to 18, right? Or 18 is going to be less than or equal to C, however you guys want to say it. But at the same time, C has to be less than or equal to 34 degrees, and C represents Celsius. So they want us to write a compound inequality, which we did right here. Okay, that's the first step. Write the compound inequality. And then write an inequality giving the temperature range in degrees Fahrenheit. So I actually have to use the formula to change from degrees Celsius to degrees Fahrenheit. So I basically pass down the 18, but instead of saying less than or equal to C, I'm going to use the Fahrenheit formula. Now, the Fahrenheit formula, guys, I'm going to write it here so you guys know that I'm not randomly just picking it. The Fahrenheit from Celsius to Fahrenheit, the formula is 5/9 times F minus 32 times F minus 32. So they want me to write the compound. The problem is asking me to write the compound inequality, which I did. 18 is less than or equal to C. C is less than or equal to 34, which means that the temperature is going to range between 18 and 34. But now they want us to change that Celsius to Fahrenheit. So instead of writing the C, I'm going to write the formula. 5/9 times times F minus 32 times F minus 32. Minus 32. And of course, that is less than or equal to 34. So all I did was I changed the value of C into the formula, and I have to change basically each temperature to 32 degrees. So what's the first thing, each temperature to Fahrenheit. So what's the first thing I'm going to do? Well, I'm actually going to I have to divide by 5/9. I have to get this 5/9 out of here because it's saying 5/9 times F minus 32. So a lot of people would say, well, then I add the 32 on both sides. That's not what you're going to do because there's a multiplication sign. So what I actually have to do is divide by 5/9. Okay, so I have to divide by 5/9. Now remember that whenever you're dividing a fraction, you're actually multiplying by the reciprocal. So in reality, what I'm going to do is multiply everything by the reciprocal of 9/5, and the reciprocal of 5/9, and the reciprocal of 5/9 is 9/5. Okay, so again, and I'm going to do it down here. All I'm going to do is I'm going to multiply. I'm going to flip the fraction upside down and say 9/5, because that's the reciprocal, right? Times 18 and then that's going to be less than or equal to, and you're going to do the same thing, 9/5 times 5/9 times 5/9. Right, times 5/9. Then you have the F minus 32. Now this is really not that hard. It's just that because I'm writing it so slow on this thing, and because I'm talking so slow, it seems like it's eternal, but it's really not. Had I had my board in the classroom, I'm pretty sure I'd be done with this by now. And is less than or equal to 9/5 times 34 times 34. So what we're going to do is, first of all, this is all going to cancel out. This is all going to cancel out, and I'm not going to have this here anymore. So I know for a fact that I'm going to have less than or equal to F minus 32, because the 5/9 and the 9/5 cancel each other out because they're reciprocals of each other. So 32 2. And now what we need to do is just multiply each side by 9 over 5. So normally you would try to see if there's anything that you can cross cancel, but you can't if nothing cross cancels here. So what I'm going to do is I'm going to multiply 18 times 9. And then after I do that, I'm going to divide my answer by 5. Okay, so that's what I'm going to do. So 18 times 9, and then divide that answer by 5. And if you multiply 18 times 9, your answer is going to be 162. And then divide 162 by 5, and that would be 32.4. So here, the answer that I'm going to get, and let me write it in a different color so you guys understand what I did, is 32.4. 32. Sorry about that. Let's see if I can write it better. So that's going to be 32 0.4. Again, I got the 32.4 because I multiplied 18 times 9, which is 162, and divided 162 by 5, which is a 32.4. Now I'm going to do the same thing on this side. I'm going to multiply 34 times 9, and then that answer divide by 5. So let me get a different color for that one. I'll use green. So you're going to multiply 34 times 9, which is 306, and divide that by 5, which is 61.2. So this is going to be 61.2. Now I'm not done yet because I have an F minus 32. So I'm actually going to go ahead and erase all this that we did prior so that way I have more space. Okay. So I realized I mistakenly erased part of the answer I just got. So I'll fix that. So I'm going to erase all this, and this is what I'm going to need to change everything to the way I want it. In fact, let me just erase this and write it up here, because that way I have more space. So we got that 32.4. 32.4. I'm just writing up here so I have more space, as less than or equal to F minus 32. And again, you can always go back and pause and rewind the video and see, try to, if you got lost, see where the error was or what made you get confused, although this is really not that difficult. It's less than or equal to. It's just a little tedious. I'll grant you that. It's a little long. 61, I believe it was 61.2. Okay. 32.4 and 61.2. 61.2. Okay, so let me erase this down here. Now, to finish my exercise, all I need to do is get rid of the 32. And when I get rid of the 32, then I will have my answer as a compound inequality for Fahrenheit. So I'm going to add 32 on both sides so I can get rid of it. Every side I'm going to add 32. So I'm going to add 32 here. And with decimals, of course, you just add the 0.0. Add the 32. And you're going to add 32 on this side. And this is going to cancel out, obviously. And then 32 plus 32.4 plus 32. Again, you just add the 0.0. That would be 64.4. 64.4. And then, of course, is less than or equal to f because the 32 canceled out. So we say less than or equal to f. And now we're going to do the same thing on the other side. And we're going to less than or equal to, and we're going to add. And again, just add the 0.0 here if, and that way everything is okay and no one get confused. And that would be 2, and 1 and 2 is 3, and 6 and 3 is 9. So that would be 93.2. And that is example number 7, ladies and gentlemen. Again, the first thing I did was I wrote it as a compound fraction because it says that the temperature of the monitor lizard ranges from 18 degrees Celsius to 34 degrees Celsius. So that means 18 is less than or equal to 32 to C, which is less than or equal to 34. Then I used this formula, which is to convert from Celsius to Fahrenheit. And then the first thing I did was I multiplied by 9/5 on all sides. And I multiplied, and that's where I got the 32.4, and that's where I got the 61.2. And of course, the 5/9, when I multiply 5/9 by 9/5, this 5/9 here canceled, and that left me with f minus 32. To find the value of f, I added 32 on all sides. This side is 64.4, and the other side is 93.2. So that means, ladies and gentlemen, that the Fahrenheit temperature ranges from 64.4 degrees to 93.2 degrees Fahrenheit. So hopefully this video was helpful and it'll help you clarify and be able to do the work that is already posted on the LMS. So guys, until we see each other in our next class, stay safe. Bye-bye.